Hey guys, welcome back to another video. In this video, we're going to be talking about high-level versus low-level languages. But let's just talk for a few minutes about this idea, language hierarchy. A wide range of languages exists, both natural like English and artificial like Scratch. Ultimately, language is a tool for communicating an idea. In computing, this communication may be human, machine, or anywhere in between. At the high end of that spectrum lie the languages that are best for human communication. These languages are complex and use a high-level abstraction, a concept that we're going to look at more in Unit 3, Data Representation. They are symbolic and rely on strings of letters to form words that represent abstract concepts, ideas, actions, and objects. Our brains are optimized for this form of symbolic expression, so these languages are easy for us to read, write, and understand. Different programming languages offer different levels of abstraction. Examples, we'll look at a few here in a second, but with all of their abstraction, inconsistent grammar, and usage, natural languages are difficult to use in ways that machines understand. The technology has made great strides in recent years with products like Apple's Siri and Google's OK Google voice search. But there's still a long way to go before machines can truly understand natural languages. Low-level languages, however, are optimized for machines. Computers are built using highly structured circuitry that responds to very logical and clear signals. Because low-level languages are much more concrete and straightforward, with limited vocabulary and very structured syntax, nothing is left to interpretation. Machine languages are the most basic type of computer language. They represent the actual binary instructions issued to computer processors and are very difficult for humans to read. They may also vary from computer to computer. Believe it or not, in the beginning days of computer programming, all programs were written in binary machine language. Today, that's very rare. The table on your screen right here outlines the language hierarchy. Notice that the natural languages in the first row, such as English, are suited only for humans, and processor-specific languages in the last row, consisting of ones and zeros, are suited only for machines. But the languages in between bridge that gap. Both high-level programming languages like Scratch, C++, and Python, and low-level programming languages that tell the computer processor what to do, but are still somewhat readable by humans, allow humans and computers to communicate with each other. The high-level and low-level programming languages in the middle of the table are uniquely well-suited for computer scientists because they are abstract enough to feel natural and intuitive to humans. But they're basic and structured enough for machines to process with the level of precision that is required. High-level programming languages, over the next few units, you're going to get the chance to work with two different high-level programming languages. We're going to work with Scratch and Python. Scratch is a visual programming language that allows you to drag and drop blocks to communicate with the computer without worrying about spelling, punctuation, and other things. Python is a textual programming language. Because of the abstraction in most high-level programming languages, people can program without needing to worry about the specific configuration or design of the computer's underlying circuitry. And this allows programmers to focus solely on the task of designing and coding a logical solution to their problems. Languages like Scratch and Python are platform independent, meaning that the programs you write will run on just about any modern computer, regardless of the model, operating system, or maker of the hardware. Low-level programming languages are a little bit different. They're on the other side of the spectrum, and these languages are entirely dependent on the underlying hardware. The language the computer uses is specific to the individual processor within the machine. That is, there's a direct correlation between the ones and zeros of the binary code and the billions of microscopic electronic switches embedded within the circuitry of the computer. Fortunately, most programmers never need to actually work at such a low level or program directly with ones and zeros. Instead, software development tools such as Scratch and Python interfaces automatically generate the low-level binary code that the processor requires. They do this by interpreting your high-level abstract instructions into lower-level machine code through a process known as compilation. And we're going to explore that in another video. But thanks guys for watching. Hope you all have an awesome day, and I'll see you all in the next video.